We will discuss here the topic, transistor is a switching device. Before going through actual topic, let us know, what does a switch do? It offers open circuit when it is off, and offers short circuit when it is on. In other words, it can be said that a switch provides infinite resistance during its off condition, and provides zero resistance during its on condition. Hence, a switch can be imagined as an off-controlled resistor, which provides either zero or infinite resistance to the circuit without any intermediate value. A transistor, on the other hand, can be considered as a controlled resistor, as the resistance between emitter and collector is controlled by current in the base emitter junction. By controlling base emitter current, the emitter-collector resistance can be made either nearly infinite or nearly zero. A transistor gives quite a large resistance to the circuit, but it is not ideally infinite, also gives very small resistance, but it is also not ideally zero. In a transistor characteristic, there are three regions. They are cutoff region, linear region, and saturation region. In linear region, for wide range of collector-emitter voltage VCE, collector current IC remains constant. As the voltage has a wide range and collector current is almost constant, there will be significant power loss if the transistor is operated in this region. But, in a practical switch, when it is off, the voltage across it will be equal to open circuit voltage, but the current is zero, hence, there is no power loss. Similarly, when the switch is on, the current through the switch is as high as short circuit current, but the voltage across the switch is zero, hence, there is no power loss again. When we want a transistor to be operated as a switch, it must be operated in such a way that the power loss during on and off condition should be nearly zero or very low. It is only possible when the transistor is only operated in the marginal region of the characteristics. There are two marginal regions in the characteristics of a transistor, and these are cutoff region and saturation region. In the figure, when base current is zero, the collector current IC will have very small constant value for a wide range of collector-emitter voltage VCE. So, when the transistor is operated with base current less or equal to zero, the current through the collector to emitter IC is very tiny, hence the transistor is said to be in off condition, but at the same time, power loss across the transistor switch, that is IC into VCE, is negligible. Because of very tiny collector current IC, hence, the transistor is said to be operated as off switch. Now, suppose the transistor is connected in series with a load of resistance, RL. In normal condition, the voltage across the load is VL. Hence current through the load is IL equals VL by RL. If the transistor is operated with a base current IB1, for which collector current is IC1, if the load current VL by RL, that is IL, is less than IC1, then the transistor is operated in saturation region. Here, for any current less than IC1 through the transistor's collector to emitter, there will be very tiny collector-emitter voltage VCE. Hence, at this situation the current through the transistor is as high as load current, but the voltage across the transistor VCE quite low. Hence power loss in the transistor again is negligible. The transistor behaves as approximate short-circuited switch, or on switch. So, for using the transistor as a switch, we should make sure that the applied base emitter current must be sufficiently high to keep the transistor in saturation region for given load current. So, from the previous explanation, We can conclude that the transistor behaves as a switch only when it is operated in cut, off, and saturation region of its characteristic. In switching application, the linear region of characteristics is avoided. As we already told, the power loss in transistor switch is very low but not zero. So, it is not an ideal switch but accepted for specific applications.